one of the rules. If you react with elemental oxygen, right, it's a redox reaction. Plus we can tell here because what happened, we have a metal and a non-metal, both of them neutral, and they form an anionic compound. So redox reaction. What do we have here? Actually, this is what do we have? HBr is an acid. Calcium hydroxide is a base, right? This is acid-base neutralization reactions. Acid-base neutralization reactions are not redox reactions. There's no transfer of any electrons. So this is not a redox reaction. Not a redox reaction. Okay? Acid-base neutralization reactions are not redox reactions, right? Most precipitation reactions, we gotta be careful with that one. Most precipitation reactions are not redox reactions either. Most of them, right? But you gotta be careful with that one. Let's take a look at this. Calcium plus chlorine. Again, these are elemental form, right? No charge. What happened there? It formed an anionic compound. So the calcium is transferring electrons to the chlorine atom. So this is a redox reaction. Right? Metal plus non-metal. Ionic compound, what do you have? You have to have ions. So the calcium's plus, chlorine's negative. Thus, we had to have a redox reaction for that to occur. Right? Let's take a look at one more. Whoops, I got that backwards. I'll just leave it that way. I think that's okay. All right. Let's take a look at this, right? Here we have zinc 2 plus aqueous, right? What happened? Here zinc no longer has a charge, okay? Here Fe doesn't have a charge, now Fe has a charge. What happened? Well, you transferred 2 electrons from the Fe to the zinc. You don't need to know that, okay? But that's what happened, you transferred 2 electrons. Anyway, all you need to realize is that here this has a charge, here it doesn't. Electrons had to be transferred, okay? So this is a redox reaction. All right? I hope I explained that so it makes somewhat sense, right? If not, I guess you have to email me or check in your book or look online or something. Got one last part. Classifying chemical reactions, which is actually pretty straightforward. We're going to have 4 basic types of reactions. There's more than that technically, but for our purposes in this class, we'd have 4. Let me write these down. I'm going to put, well, first I'm going to make this. Classify chemical reactions, okay? We're going to have 4 types, basically. We have type of reaction here. Here I'm going to put generic example, and then here I'm going to put a real example. So first we're going to have synthesis or combination reaction, same thing. Synthesis or combination, just what it says. We're going to have A plus B, they're going to combine, you're going to form C. For a real example, we had this on the board earlier. okay? It doesn't matter that there's two of them. It's A plus B equals C. Combination reaction. We're combining sodium and chlorine. Then we have decomposition reaction. That's actually the opposite of the first one. It's the opposite, okay? So we're going to have C is going to break down to A plus B, right? So I could reverse this equation, but here I'm going to use this. We'll say we have H2O, and you run a current through it, and we're going to make H2 and O2 gas by running a current through. It causes it to decompose. So pretty straightforward, okay? One thing breaks down into two or more things, usually two. Then we're going to have single displacement. We're going to have A plus BC. So basically A is going to displace B is what's going to happen. And we're going to end up with AC plus B, like that. You know, say look at a real world example. If I have enough room here. Ooh, I'm not going to have enough room. Ah, crapola. So you have more room probably. So I'm going to erase this so I can write this here, so I can fit this. Should have moved this over. Real world example. Zinc solid plus copper chloride aqueous. Zinc's going to displace the copper, and we're going to get zinc chloride plus copper solid, like that. Okay? And then finally, double displacement. A precipitation reaction is double displacement. Most acid-base neutralization reactions would also be double displacement. Here, so we can make myself in a room, make sure I got enough room. AB plus CD. So A and C are going to, so A is going to go with B, C is going to go, A is going to go with D, sorry, A is going to go with D, C is going to go with B. And we're going to get AD plus CB. Like I said, that'd be a precipitation reaction. Okay, again, there's not enough room here. I'll write it down here for the example. But again, whatever precipitation reaction you might have, something like this. So AgNO3 plus NaCl. Silver is going to go with the chlorine. It's going to precipitate. And then sodium is going to join up with the nitrate. And that's aqueous. So that's double displacement reaction, okay? Again, synthesis or combination, join two things usually together. Decomposition, reverse that. One thing breaks up into two or more things. Single displacement, and then double displacement. Again, double displacement will usually be a precipitation reaction or a acid-base neutralization reaction. And that's all there is for Chapter 7.